Thank you. So I'll be talking about the baseline monitoring that ReefCheck has done here on the North Coast. But before I talk about the results from up here, I just wanted to introduce ReefCheck. So ReefCheck California is a program of the International ReefCheck Foundation. And what we do is train scuba divers, volunteer scuba divers as citizen scientists to monitor the rocky reefs and kelp forests all along the California coast. And we do that first and foremost to inform management and policy so that they can make science-based management and conservation decisions. And then also to foster an educated public that's supportive of these science-based decisions, hopefully. So how do we do our surveys? Basically, we teach the volunteers to count and size fish, invertebrates, and algae along these standardized transects. And those methods are actually really similar to the PSCO methods that Sean was talking about earlier. So we survey rocky reefs between 5 and 18 meters, so basically diver depth, and try to distribute our transects, so each of these little lines is a transect across the entire reef, so we capture the whole depth range. And we do that by placing 18 transects, which are basically these meter tapes along which we count and size the organisms. And we target 73 species of fish, invertebrates, and algae. And we chose those, and they're the same species statewide, and we chose them because they're either ecologically important or they have high economic importance. And then they also have to be somewhat easy to identify so that we can teach volunteers in a reasonable amount of time. And we've done this for over 10 years now. We started in 2006 and have developed, so there's the map of all our sites in California. So we have developed this network of around 90 sites. And for many of them, we have more than 10 years of data now. Lots of them dating back to pre-MPA implementation, and then now lots of sites inside and outside of MPAs, which we survey annually, and we train about 250 volunteers every year to do this. So what have we done then in the North Coast? And so in 2014 and 15, the two baseline years, we held 12 trainings and recertifications. So trainings are for new volunteers, and then recertifications are for volunteers that come back after they have already been trained in previous years. And so we trained about 140 community members, all of the scientific divers at HSU, as well as through a new partnership with UC Davis. We train the scientific divers at the Bodega Marine Lab now, and they have come up to the North Coast to do surveys as well. We have established 8 monitoring sites. They're all in Mendocino County. Here's Fort Bragg. And have conducted 18 surveys at those sites over the 2 years. And by doing that for 2 years and by having all these these trainings, we built the capacity to continue this long-term monitoring, which was one of our goals, to use these 2 years really as the starting point for long-term monitoring. And so we have a group of ReefCheck volunteers up in this region now. We have the regional manager, and we continued monitoring those sites in 2016. And we actually just started our first survey last weekend for the 2017 season. So as far as the results from the baseline monitoring period, I wanted to talk about 3 things. The community structure that we found along those sites, and then I'm going to talk about one marine protected areas, the Point Cabrillo SMR, and show you some comparisons of species, densities, and sizes inside and outside of that MPA. Really similar to what the other kelp forest group did. And then I want to put those results in a long-term context because of all the funky ocean conditions and diseases that we've been talking about. So these are our sites again in Mendocino County. And so what I've done is I've used a cluster analysis, which is really similar to the MDS plots, and I'll show you some MDS plots too. But basically, this groups the sites into sites with similar fish communities. And so you can see we have these 3 sites in the southern part of the region that are similar to each other, and then these sites further north that are similar to each other. And Glass Beach is kind of an outlier up here. And if we look at what drives these differences, it's mainly the abundance of the foremost, or the densities of the foremost abundant fish species, and those are black rockfish, blue rockfish, kelp greenling, and striped perch. They were most abundant at all of these sites, but much more abundant at those green sites up here. And then additionally, we also find a higher species richness at these sites compared to the southern sites in the fish species. So some of the not like rare rockfish species are found up here, but we don't see them down there. And you can also see this in an MBS plot. So this is similar to what other people have shown you. So if sites are close together, they're more similar to each other than when they're far apart in this type of an analysis. And so you can see that all these green sites cluster really closely together. And I kind of blew this up here because you can, oh, sorry. Because you can't really read this here, but this is the same data. And what I've done additionally here is I overlaid the exposure of these sites to ocean swells and waves. And so it's not only a geographic separation in these communities, it's also that these northern sites are much more exposed than these three protected southern sites. This is just in here to remind me to tell you that we didn't find that kind of community structure in the invertebrate communities. So all sites that we surveyed look fairly similar if you compare the invertebrate communities. And again, in an MBS plot, you can see that there's no clear clusters of sites other than a few sites that are really close together. But overall, they're all comparable. So now I want to focus on one MPA, the Cabrillo SMR, where we have three sites. Freiwald Cove site is inside the protected area, and then we have two sites outside, Casper and Casper North as reference sites. And so if we look at the fish densities inside and outside of these SMR, and that's what I've done here. So I plotted the densities for the four abundant fish species: black rockfish, blue rockfish, striped perch, kelp greenling, and then also for cabezon and lingcod down here. Across those three sites along the bottom, Casper North, Casper, and then Freiwald Cove, the protected site in red. And if you just look at all these six graphs kind of together, there's no clear trend of species densities being higher in the MPA versus outside of the MPA. Actually, in fact, for blue rockfish, it seems a lot lower. For some species, it seems high, but there's no significant differences. But if we look at the size distributions, we get a different picture. And so I'm going to show you two slides like this. One for kelp greenling over here on the left, and one for striped perch, and then one for the rockfishes. But just to orient you on these, I plotted the size on the x-axis in 5 centimeter size bins, and then that's the percentage of individuals we found in those bins on the y-axis. The blue line is the size of first maturity for these species. And then I also indicated the median size at those three sites. And so you can see for kelp greenling, we see a lot more large individuals inside the MPA. And similarly for striped perch, we see many more large individuals in the MPA. And if we actually compare these distributions statistically, we find that the reserve has larger fish than the fish sites for both of these species. Really similarly for the rockfish, so black rockfish over here, blue rockfish on the right, we see a really strong pattern for black rockfish with a lot more large individuals, mature individuals in the MPA, whereas we see hardly any mature individuals outside of the MPA. And then blue rockfish, we do see a little increase, but this is kind of funky because these are all very small individuals, 8 centimeters, median size. So those are all recruits. They're 1 or 2 year old individuals. So I would not, even if we see a significant increase here, those are still all very small fish. And it's actually interesting that we hardly see any large mature blue rockfish at these three sites. So now the same graphs for some invertebrates. So bat stars over here, red abalone, next to it California sea cucumbers, anemones, and then purple and red urchins. And so again, we don't really see a clear trend if we look across all of these species for density increases in the MPA. It does look like abalone a little more abundant in the protected area than outside. And interestingly, we saw very low densities of urchins, purple urchins or red urchins, in the protected area compared to outside areas. And then when really the only invertebrate for which we collect size information is red abalone. And if we compare the size distributions, again, across these three sites, we do see significant differences between those three sites, but actually the largest abalone are found at Caspar North by quite a bit compared to the other two sites. So we don't see an MPA effect for the size of the species yet. But so now I wanted to kind of put these results into perspective, looking at some long-term trends. And so how do these baseline years that have been so funky with the warm blob and then the sea star wasting disease, how do they compare to the long-term trends at some of these sites? And 3 of the 8 sites that we monitored for the baseline, these 3 sites down here, we have actually monitored since 2007. And so I'll show you some long-term trends from those 3 sites. Okay, so I'll show you several graphs like this. This is basically the years from 2007 to 2016, and then the density of different species on the y-axis at Mendocino headlands in blue, Portuguese beach in red, and Van Dam in yellow. And this is for the sunflower stars and giant spine stars, Paisasa. And so you can see they were fairly abundant with some variability at those 3 sites until the sea star wasting disease hit basically at the end of 2013. And then in our first survey after that in 2014, we didn't see any more sunflower stars. And what you can't see in this graph, because there aren't any, I also put bars on here for summary of all 8 sites. And so we did not see any stars at any of those 8 sites in the baseline years or in 2016. And then similarly for Paisasa, in 2015 and 16, they were completely absent from all of our sites. So then what did that do to the urchins? So the sunflower stars are really the major urchin predator, especially for purple urchins in this, not just in this region, also in Central California. And so you can see again the same type of graph. Purple urchins were present at all of these sites, but at very low densities, and as is were red urchins. And they were actually a little bit more abundant than purples prior to 2014. As the sea stars disappeared, the purple urchins seemed to explode. So we get over 100-fold increases between 2014 and 15, and it seems to be going up further in 2016. Similarly for the red urchins. And here you can see now these data from the long-term sites seem to be representative of what's happening at all 8 baseline monitoring sites for the last 3 years as well. One more set of graphs now for the kelps. So on the right is bull kelp, Nereocystis, and on the left. And then on the right is Pterogophora. So that's an understory kelp that doesn't grow all the way up to the surface, but can form dense canopies of kelp below the surface. And so, again, bull kelp was fairly abundant at all of these sites, pretty variable over the years, but then starting in 2014, it pretty much disappeared at the same time as the sea stars disappeared. And so this disappearance of kelp might not have been the result of urchins increasing, because it seems like the urchin increase came a year after the kelp disappeared. But now the high urchin presence definitely contributes to the kelp not coming back. And then the Pterogophora seems to be declining with a year lag after the bull kelp was gone. Now the understory has disappeared too. And so basically, all of these sites have turned from something that looked more like this, where you have kelp forests with several layers of canopy the bull kelp going all the way up to the surface, and then a sub-canopy here that provide lots of structure for fish and food for invertebrates to something that looks more like this. So there's no more kelp left, and the last few dying stipes are just overrun by urchins that are eating them up and not letting the kelp grow back. So in summary then, the kelp forest communities along the Mendocino coast are structured, and we see different fish communities at different sites. We have some evidence that fish are already growing larger in the marine protected areas. No changes in their densities yet, but that's to be expected after only a few years. It seems like that sea urchin densities are lower in the marine protected area than outside, and so that'll be interesting to see how that develops and if that might provide some potential for kelp recovery. And then I think the most important point is that kelp forest communities during the baseline monitoring years, or you can hardly call them kelp forest communities anymore, right? There's no more kelp. They look really different than what they have looked like in previous years. And the kelp forests basically have turned into urchin barrens. So going forward then, ReefCheck has built the capacity for citizen science monitoring of these MPAs in the North Coast. And we really need these long-term annual monitoring programs to understand the MPA effects, and not only the MPA effects, but also to put them into perspective with other ongoing changes such as climate change, diseases, or invasive species, because we've seen how massively and rapidly those kind of changes can affect these systems. And we're planning to do that into the future, and to integrate the North Coast monitoring with the statewide MPA monitoring that we're already doing. And with that, I just wanted to thank all the citizen scientists, volunteers. We have kind of small teams up here in the North Coast, but they're really dedicated, and they like getting involved, and they want to continue this monitoring into the future. Okay, thanks. I think we have time for some questions, right?
Yeah, I'm timing you. Yeah, Brian, yeah, we have 4 minutes.
Joe?
Yeah, correct me if I'm wrong, but it seems like the pattern you saw at Cabrillo of more, fewer urchins and more abalone sort of contrasts with what the HSU guys saw.
Yeah.
Have you guys put your heads together to try and reconcile why those patterns might be different?
We just started doing that over lunch, yeah. One thing that's different, so I didn't get a chance to talk about that, but the Point Cabrillo Reserve has kind of two areas, one that has been protected for a long time, and then it got expanded during the MPA process, and so the ReefCheck site is in the newly protected area, whereas I think the HSU sites, at least most of them are in the old part, so that might have something to do with it.
Yeah.
Do you see any prospect for recovery or any arc that might go forward that would give one hope that that ecosystem would rebound?
That's the question right now. I don't know. We have not seen any recovery yet. There's definitely efforts in other regions to try to remove the urchins and see if there's a chance for the kelp to come back, but yeah, so far we haven't seen a change. What often happens when the urchins get that abundant is they're going to die off at some point, because they kind of run out of food as well, and so maybe there's some hope there.
Yeah, I was just going to add, anecdotally, I've been out in Trinidad, I've been out off the Mattole, I've hiked from the Mattole River to Shelter Cove within the last 2 weeks, and I do it fairly regularly, and I've seen a lot more kelp in the last 2 or 3 weeks than I've seen in the last 2 or 3 years. So if that can provide a ray of hope, I hope.
Well, that's Gorda in between, and so
Yeah,
they're like different ocean worlds.
Right. Well, I've seen it north of the Mattole Canyon too, in Trinidad, not to the extent that I've seen to the south.